Good morning and Sairam to all. In this video, we will go ahead with our chemistry chapter, that is matter or surrounding. So, in previous video, we have done that how matter can change their state. I told you that matter can change their state by two ways. Number one, by change in pressure. Number two, by change in temperature. We have already done that how matter can change their state by change in temperature. So, first we will revise it how matter can change their state if we change the temperature. Here is a diagram how matter can change their state by change in temperature. So, if your matter is in a solid state, and we will raise the temperature, what will happen? It will convert into liquid. If it will convert into liquid, that process is known as your melting process. Because here your solid substance melt and convert into liquid. So this process is known as melting. And one more name is there. It is also known as fusion. So when your solid substance convert into liquid substance, that process is known as melting, or that process is known as fusion. Okay, now if your substance present in a liquid state, and convert into gas, how it will convert? If you will increase the temperature, okay, and that process is known as evaporating. That process is known as your evaporating. That means if your liquid substance change into gas by raising temperature, that is known as your evaporation. Clear? Now I told you that some substance are there which directly some solid substance are there which directly convert into gas and gas to solid, and that process is known as your subliming. Clear? Now if we will see this, that if you decrease the temperature, that means take the example of water. If you will decrease the temperature of water, it will again convert into solid, and that process is known as your solidifying or freezing. What do you mean by solidifying or freezing? That means if your liquid state again convert into a solid state, or your liquid convert into solid state, is known as your freezing or solidifying. How it will convert? If you will decrease the temperature. If you will decrease the temperature of any liquid, it will convert into a solid form, and that process is known as your solidifying or freezing. Clear? Now, like this, if you will decrease the temperature of gas, it will again convert into liquid. I gave you example of milk. If you will boil the milk, or if you will boil the water and you will switch it off the gas and you will put that plate on it, after some time you will see that some water droplets on the top of the plate. What it indicates that? It indicates that vapors which are coming out from the milk or water, it will stuck with that plate and it will stuck over there, and After some time, when temperature decreases, again that gas vapor converts into liquid form. Again that gas vapor converts into a liquid form, and that is known as your condensation. That process is known as your condensation process. So when your gas convert into liquid state by decrease in temperature is known as your condensation. And if your gas again convert into solid, that is your reverse subliming process. I gave you example that camphor balls, then naphthalene balls which you are using for kept where? In a store box, in your almirah. These all are the sublime example. So I think this is clear to you. What is condensation, what is freezing, what is solidifying, what is sublime. So now we will go ahead with our syllabus. Topics to be covered is latent heat. Okay, latent heat. Now let us start. See, latent. Latent is a Greek word. It is a Greek word. It comes out from a Greek language and it means hidden. It means hidden. See, if you want to change a state of matter, what you will apply? You will apply heat, and heat is a one type of energy. So, latent heat is a hidden heat. You can say that. What you can say that? Latent heat is a hidden heat which you apply to the substance by the help of this heat, a substance can change their state. So, it is known as your latent heat. So, we can write the definition of latent heat like this. The heat energy. What? The heat energy which has to be supplied. To change the state of matter. Of a substance. Is called its latent heat. What is latent heat? Latent heat is a heat which has to be supplied for change the state of matter is called a latent heat. Okay, see, there is a one main property of a latent heat, and what is that? Yes, latent heat does not increase the temperature. Clear? That's why it is known as a hidden heat. Why? Because we are applying heat, but it will not change the temperature. Why? Because that heat is converting, and it is we are using that heat to change the state of matter. Clear? Now we will take one example. You will take a crushed ice in a beaker. Clear? Put suspended thermometer on it like this. Here you have taken some crushed ice. Here you have suspended thermometer. Here you will apply heat with the help of small burner. Before applying heat to that beaker, just note down the temperature. It is a 0 degrees Celsius. Clear? Now, if you will apply heat on that, what will happen? Ice will start melting. Now, after 5 minutes, you will see some ice will convert into water. But if you will notice the temperature, it will not change. It will remain as a 0. So, where is heat is going on? What happened to that heat? Yes, that heat is changing the state of matter. That means that heat is breaking down the bond between the water particles. Clear? And it will convert that water particles into a liquid state. Even a small drop of a small piece of ice in there, it will not change the temperature until and unless it will full convert into liquid form. When it will convert into a liquid form, the temperature will start increasing. Why? Now your water will convert into gas. And what is the boiling point of water? It is 100 degrees Celsius. Until and unless your water reaches 100 degrees Celsius, its temperature will increase. Because here, your all solid converted into liquid. Change of states of matter taken place. Clear? So we can say that latent heat is a hidden heat. Latent heat is a hidden heat which requires to break the bond between the substance, and it convert, or you can say that it overcome the bond energy between the particles. Clear? Now, so you can write the definition: the heat energy which has to be supplied to change the state of substance is called its latent heat. Is called its latent heat. Now, second point is latent heat does not raise the temperature. Why? Because it changes the state of matter. That energy requires to change the state of matter. Clear? Now, why latent heat does not cause a rise in temperature of the substance? I told you that the latent heat which we supply is used up in overcoming the force of attraction. I told you that? Yes, it is used in overcoming the force of attraction between the particles of substance during the change of state. During the change of state. So, your latent heat is a hidden heat which is required to change the state of the matter. See, I gave you example, water. See, till your temperature reaches 100 degrees Celsius, your water cannot convert into gas. Why? Because that energy is, what that heat is doing? That heat is weaken the bond between the particles. Okay, after it reaches 100 degrees Celsius, that bond completely dissociated and directly converted into gas. Clear? But that energy convert liquid into gas. Clear? So, while latent heat does not cause a rise in temperature of the substance, the latent heat which we supply is used up in overcoming the force of attraction between the particles of substance. Between the particles of substance during the change of state. During the change of state. Clear? Now, there are two types of latent heat. How many types? There are two types of latent heat. Number 1, latent heat of fusion. Number 2, latent heat of vaporization. How many types of latent heat are there? There are two types of latent heat. There are two types of latent heat. Number 1, latent heat of fusion. Number 2, latent heat of vaporization. Number 1, latent heat of fusion, and number 2, latent heat of vaporization. So, let us first do latent heat of fusion. As we all know that, what do you mean by fusion? What do you mean by fusion? We have done earlier. Yes? Tell me fast. Yes. Fusion is a process in which a substance change into solid state to liquid state, and that process is known as your fusion. That process is known as your fusion, and fusion is also known as your melting process. Fusion is also known as your melting process. So, what do you mean by latent heat of fusion? The hidden heat which converts solid into liquid form. That heat is known as your latent heat of fusion. Okay, so the latent heat of a fusion or a melting of a solid is the quantity of heat in our joules. It is a type of energy. So what is a unit of energy? It is joule. Heat in joules required to convert 1 kg of solid, clear, at its melting point to liquid without change in a temperature. That means that energy which help us to change the state of matter without raise in temperature is known as your latent heat of fusion. What do you mean by latent heat of fusion? That hidden heat which converts solid into liquid without change in temperature. That heat is known as your latent heat of fusion. Clear? I gave you example of ice. If there is a small piece of ice is there, temperature will not change. Why? Because that heat is converting that ice into liquid form. Clear? After this experiment, we have get the value of how much heat is required to converting that ice into water. So converting 1 kg of solid ice into water, 3.34 into 10 to the power 5 joule per kg. That means if you want to convert 1 kg of solid ice into liquid state, so how much heat you will require? You will require 3.34 into 10 to the power 5 joule per kg. Clear? How much? 3.34 into 10 to the power 5 joule per kg. Clear now? Now, the latent heat of fusion of ice is 3.34 into 10 to the power 5 joule per kg. Heat energy is used up in changing state of solid substance by overcoming the force of attraction between its particles. I told you this earlier. Okay, latent heat is a heat which overcome the force of attraction between the particles. I am reading once more. The latent heat of a fusion or melting of a solid is the quantity of a heat in joules required to convert 1 kg of the solid to liquid without any change in temperature. The latent heat of fusion of ice required 3.34 into 10 to the power 5 joule per kg. Heat energy is used up in changing the state of solid substance by overcoming the force of attraction between its particles. Clear? Now, shall we move ahead? Now, what do you mean by latent heat of vaporization? We know that. What do you mean by vaporization? Vaporization means if your liquid converted into gas. If your liquid converted into gas, that process is known as your latent heat of vaporization. That process is known as your vaporization. So what do you mean by latent heat of vaporization? That hidden heat which requires to convert liquid into vapors, which converts liquid into vapor, is known as your latent heat of vaporization. So what is the definition of latent heat of vaporization? The latent heat of vaporization of a liquid is the quantity of heat in joules required to convert 1 kilogram of liquid at its boiling point to vapor or gas without change in temperature. Without change in temperature is known as your latent heat of vaporization. It is known as your latent heat of vaporization. What do you mean by latent heat of vaporization? That heat which required to convert 1 kg of liquid into gas. Clear? If you will convert 1 kg of water, that means 1 liter of water, into vapors, how much heat is required? By experiment we will got the value, and it is 22.5 10 to the power 5. 22.5 into 10 to the power 5 kilojoule per kilogram. Clear? So it is 22.5 into 10 to the power 5 joule per kg. So this much amount of heat you will require to convert 1 kilogram of water into gas. Clear to you? Now the heat energy supplied to boiling liquid is used up in, I told you that where it is used up in changing the state of matter, and it will not raise the temperature of liquid, and it will overcome the force of attraction between its particles. So it is written over here, the heat energy supplied to the boiling liquid is used up in changing the state of liquid substance by overcoming the force of attraction between its particles. Clear? So we have done that. How many types of latent heat are there? Two types of latent heat are there. Number one, latent heat of what? Fusion, and number two, latent heat of vaporization. What do you mean by latent heat? Latent heat means hidden heat which convert your state of matter. Clear? Fusion means liquid, solid to liquid, and vaporization means liquid to gas. Now our next topic is effect of change of pressure. Effect of change of pressure. I told you that you can change the state of matter by two ways. Number one, by change the temperature, which we have done already, and second is by change the pressure. Now how you can change? See, physical state of metal can also be changed by changing the pressure. For example, gas can be changed into liquids by change in pressure. Okay, now by increase in pressure. If you will increase the pressure of gas, what will happen? The particle of gas come close to each other. Yes, if they are come close to each other, the space between the particles are less, and now this time the force of attraction between the particles are more. Now this is that in that case your gas convert into liquid state. So like this, by change in pressure, you can change gas into liquid. Clear? See, if you are having injection, okay, here you have some put gas. Gas particles are there. If you will apply pressure on it, okay, now in second case, the piston is here and gas particle will come close to each other. Why? Because you are pressuring, you are applying some pressure on it. If you will apply some pressure on it, what will happen? The particles come close to each other. If the particles come close to each other, it will change the state of matter. It will convert gas to liquid. Now another, some solid can changes into gas on decrease the pressure. If you will decrease the pressure, what will happen? If you will increase the pressure, the particles come close to each other, and if you will decrease the temperature, what will happen? The force of attraction between the particle become weak, and the force of attraction between the particle become weak, and they can move here and there. Okay, like this you can convert solid into gas by decrease in pressure. Now there are some example. Ammonia gas can be liquefied. If you will, what is the formula of ammonia? It is NH3. So it is a gas. If you will increase the pressure, the particles of ammonia come close to each other. If it will come close to each other, the force of attraction between the particle become more, and the space between the particle become less, and this is a property of which state of matter? This is a property of liquid. So like this, you can convert ammonia into liquid. Clear? By increasing the pressure and lowering the temperature. Yes, sir. I told you earlier, if you want to convert gas into liquid, you have to decrease the temperature. Okay, you have to decrease the temperature, and if we are talking about pressure, then you have to increase that pressure. What you have to do? You have to increase that pressure. Clear? Now, solid CO2. And what is solid carbon dioxide? I told you earlier. Yes, it is known as your dry ice. Dry ice stored under high pressure. Stored under high pressure. The conversion of solid CO2 in carbon dioxide gas is a change of state which is caused by decrease in pressure. If you will decrease the pressure of solid carbon dioxide, the force of attraction between the particle of carbon dioxide will become less, and they can move here and there. And like this, you can change the solid CO2 in a gas CO2. Clear? And what is CO2? CO2 is your carbon dioxide. Clear? And for that, you have to increase the temperature, decrease the temperature. You have to increase the temperature. Pressure you should decrease, and temperature you have to increase. Clear? Now, solid carbon dioxide is extremely cold. That gas is very cold, and it is used as a deep freezer food and to make ice cream cold. You love ice creams? Clear? Our next topic is evaporation. I told you what is evaporation. Evaporation is a process in which a liquid converts into gas. Okay, when you will increase the temperature, that process is known as evaporation. What do you mean by evaporation? Evaporation is a process in which you can change the state of liquid into gas by increase its temperature. This process is known as evaporation. So, here is a definition of evaporation: the process of liquid changing into vapor or gas even below its boiling point is called evaporation. Okay, when your liquid start evaporating before it reaches to its boiling point is known as your evaporation. Whatever be the temperature at which evaporation takes place, the latent heat of vaporization must be supplied. Okay, whatever be the temperature at which evaporation takes place, what thing you required? You required latent heat. Yes, latent heat is a heat which helps us to convert the state of matter. Clear? That means before reaching the boiling point, that much heat you have already given to that liquid that it can change the state of matter, and that process is known as evaporation. Vaporization is a process in which a liquid reaches its boiling point and then converts into gas. But evaporation is a process in which a liquid converts into gas before it reaches to the boiling point. This process is known as your evaporation. Clear? Now, whenever liquid changes into vapor or a gas, there are following factors which affects them. There are following factors which affects them when it converts into vapor form. When liquids convert into a vapor form. So, what are they? Number 1, temperature. Number 2, surface area of liquid. Number 2, surface area of liquid. Number 3, humidity of air. Number 3, humidity of air. Number 4, wind speed. Number 4, wind speed. That means there are 4 factors which affect the process of evaporation. Which affects the process of evaporation. And what they are? They are temperature, surface area, humidity of air and wind speed. The 4 factors which affects the process of evaporation. Clear? Now we will study one by one each of them in detail. So, what is temperature? How temperature affects the evaporation process? See, if you will increase the temperature, what will happen to liquid? Yes, the liquid particles, the kinetic energy of liquid particles will increase. Clear? If it will increase, if the kinetic energy will increase, then it will rapidly convert into gas. That means in that case force of attraction is less between the particle. Clear? So the rate of evaporation increases on the increasing the temperature of the liquid. That means the rate of evaporation of liquid can be increased by boiling it. And how you will increase the kinetic energy of particles? By applying heat. Okay, so if you want that your substance should evaporate fast, so what you will do? You will apply some heat to them. Okay, clear? Now next, surface area of the liquid. Now the rate of evaporation increases on increasing the surface area of liquid. We will take an example. You are having two types of container. One is your test tube, which look like this, and one is your china dish, which look like this. Now you put some water on this and this, and you will put some water in this. Which will evaporate more fast? This. Why? Because the surface area is more over here as compared to in this test tube. So if you want to increase the evaporation process, if you want to increase the rate of evaporation process, so what you have to do? You have to increase the surface area. If you will increase the surface area, what will happen? The rate of evaporation will increase. What will happen? The rate of evaporation will increase. So you can say that the rate of evaporation increases on increasing the surface area of evaporation. Clear? Now come to the next point. The rate of evaporation of liquid can be increased by increasing the surface area of liquid. Clear? I think. So shall we move on to next point? Now, humidity of our air. What do you mean by humidity? Basically, humidity means if in the air the water molecules are present, then we can say that the air is humid. That means if the humidity is more, your rate of evaporation is less because already water vapor are there. Clear? So basically humidity of air tells us the degree of dampness of air. Clear? Now dampness means how much water molecules are present in the air. When the humidity of air is low, that means if less amount of water molecule present in the air, if less amount of water particles are present in air, then the rate of evaporation is more because that there are more space as compared to if the water particles are more. Clear? So when the humidity of air is low, then the rate of evaporation is high and water evaporates more readily. Understood why? Because more space are there. If more space is there, then air will take more water particles. So if you want to increase, if the air is less humid, evaporation take place more fastly. Clear this point to you? Now shall we move to next point? Now when the humidity of air is high, when the humidity of air is high, in that case your rate of evaporation is low. Why? Because already water particles are present over there. If already water particles are present over there, there is no space. Clear? In that case, your evaporation rate is very slow. In that case, your evaporation rate is very slow. All of you clear to you? Humidity of air. First, what do you mean by humidity of air? Humidity tells us how many water particles are there. If more water particles are there, in that case your air is more humid. And if less particles are there, in that case your air is less humid. In the case of more water particle present in the air, in that case your evaporation rate is slow. And if less number of particles are there in air, in that case your evaporation take place more fastly as compared to humid air. Clear this point to you? Now last one is wind speed. If your wind speed is high, in that case your evaporation take place very fastly. Why? Because the water particle moves with the air. Clear? In that it moves with the air. In that case also your evaporation is take place more fastly. So the rate of evaporation of liquid increases with increase in the wind speed. Clear? If your wind speed increases, your evaporation rate also increases. So we have done that. What is evaporation? Evaporation is a process in which your liquid converts into gas before it reaches its boiling point. Clear? Now, factor affecting of evaporation is 4. Number 1, temperature. Temperature increases, evaporation process increases. Second is surface area of a liquid. If you will increase the surface area, the evaporation process rate is also increases. And if you will decrease the surface area, evaporation rate decreases. Third is humidity of air. If the air is more humid, the rate of evaporation is less. If the air is less humid, the rate of evaporation is high. And the last one is wind speed. If the rate of wind speed is high, the evaporation process is also high. Clear this? Shall we move on next topic? So, our next topic is cooling caused by evaporation. How evaporation causes cooling? Now see, the cooling caused by evaporation is based on the fact that when liquid evaporates and it draws or takes the latent heat of vaporization from anything which it touches. See, this thing is clear more to you when I will give you examples. Shall I give? Okay. So, first example is, if we put a little spirit or a petrol at the back of our hand, what we will put? We will take a spirit and a petrol. Where? At the back of our hand. And wave it around. What will happen? Yes, the spirit evaporates rapidly. The spirit evaporates rapidly and hands feels very cold. And hands feel very cold. Why? Because this is due to the fact that to change from the liquid to vapor state. Clear? Spirit requires latent heat of vaporization. What spirit requires? Spirit requires latent heat of vaporization from our hand. Now the hand loses heat and get cooled. This is an example of cooling caused by evaporation. This is an example of cooling caused by evaporation. When you will put ethanol at the back, or a petrol, or a acetone, or a spirit, and you will wave it, after some time you will feel cool. Why? Because that ethanol and that petrol take latent heat from your hand, and that liquid convert into vapor. Okay, if you will that liquid convert into vapor, that means in temperature decrease, temperature will decrease. If temperature will decrease, how you will feel? You will feel automatically cool. So this is why you feel cool. Shall I give you one example more? In summer vacation, in summer, after doing physical exercise, and when you will come under the fan, okay, your body is full of sweat. Now if you will come under the fan, what will happen? You feel cool rather than without doing any exercise. Why? Because in that case your sweat is in a form of liquid, and that sweat will take latent heat from your body. Okay, from where it will take latent heat? It will take latent heat from your body. When it will take latent heat from your body, it will convert into, yes, it will convert into gas or a vapor, and it will vaporize. And if it will vaporize, that means your temperature will decrease. Yes, that is a reason we will feel cool in a summer day after doing physical exercise when you will come under the fan. Clear? Like this, there are lots of examples, like your earthen pot, sprinkling of water during the summer days on the earth. Why you wear cotton clothes? Because cotton clothes absorb your sweat. That's why during summer you prefer to wear cotton cloth. Clear? I think this is clear to you. Why cooling caused by evaporation? Because it will take, if you will take the example of your body, whatever liquid touches your body, it will take latent heat from your body. It will take latent heat from your body, and it will convert into vaporized form. And if it will convert, that means temperature will be decrease. If a temperature will decrease, it means you will feel cool. Clear? Shall we move to next? We have done that state of matter occurs in 3 states, that is solid, liquid and gas. But there are 2 more states. One is your plasma, second is your Bose-Einstein condensate. Clear? What do you mean by plasma? See, plasma is a mixture of free electrons and ions. Nothing is that. It is a mixture of free electrons and ions. If free electrons are there, ions are there, that state is known as your plasma state. That state is known as your plasma state. Plasma occurs naturally in the stars and sun. Plasma occurs naturally in the suns and stars. So, what is the plasma state? Plasma state are those states in which free electrons and ions are present. Second is plasma occurs naturally. In which? In stars and suns. Clear? Now last one is Bose-Einstein condensate. It is a 5th state of matter. Clear? Now, what happened? In 1920, an Indian scientist, Satyendranath Bose, did some calculation for the 5th state of matter. On the basis of these calculations, Albert Einstein predicted the existence of new state of matter, and that matter is called as Bose-Einstein condensate. In short form, you can write BEC. B stands for Bose, E stands for Einstein, and C stands for condensate. Now, the fifth state of matter called BEC was finally achieved by the three scientists. Number one, Colonel, and second is your Satyendranath Bose, and third is Albert Einstein. And how they achieved this state? By cooling a gas extremely low density to a super low temperature. Clear? How you will obtain? You will obtain this state by cooling a gas. By cooling a gas at extremely low density at a super low temperature. Clear? With this, your first chapter of chemistry is completed. I think everything is clear to you. Clear? Clear? So, please note down all the important points, but in the rough notebook. And whatever homework is giving to you, please try to do in your rough notebook. If you are able to give that answer, that means the chapter is clear to you. Clear? Thank you and Sai Ram to you all.